problem in electromagnetism. You have two charges, Q, and the question is, what is the electric field in the point P? And here is the electric field from that charge, and that's the electric field from that charge. And the electric field is given by this formula here. But each vector here can be divided up in the x component and the y component, and also here. And then you see that vector in the x direction will cancel out with that direction here. So the only thing that we will have is the electric field in the y direction, and here also twice, in other words. So here we can see the electric field. That's that vector here, Ex and Ey, and there is a theta. So sin theta is that side divided by the total electric field, E here. But from the figure, that theta here, that's the same as this one divided by the distance r. And the r is just, you know, this side squared plus that side squared and the square root given here. So Ey, according to this formula here, equal E z divided by r. But the E, that's just that guy here, isn't it? And then z over r. So you have r free, r cubed here, and z. And the total field is just 2 of that. I mean, we just calculated that one. So it's 2 times that. So we have answered that question. And the second question is, if the height here, z, is very, very large, so those two guys are almost at the same spot, let's say in the origin here. So then r equals z. Okay. So 2 times Ey, 2q over 4 pi E naught, it's that guy. And then that is this, but r equals z. So it will be z squared here. So that's that. And then you have the B question. It is if we replace that charge with a negative charge instead. Yeah, obviously that vector then will not be directed upwards, but in the other direction instead. And then you can see that the y components are equal but opposite, so they will cancel out. So then there will be one x component here and another one from that vector over here. So 2ex, that's what we will get. And then you can do the same mathematics as before, and you get the final answer here. And then you get a famous formula actually, q times the distance between charges. That's the dipole moment, and it's a vector from the negative charge to the positive charge. So this is a famous formula. So that is a vector from minus q here to the q here. Thank you. Subscribe, like if this was useful.